Hello everyone, today I'm going to talk about human-caused climate change and explain what scientists actually measure and observe. My objective is to present the information in a clear and straightforward way. I'll walk through the basic science, the impacts we can already see, and the solutions that are being developed. Next is our presentation overview. First, I'm going to go over the greenhouse effect and the carbon cycle, and then I'll show how fossil fuels disrupt these natural systems. After that, we'll go over the ecological and human health impacts that scientists have already measured. Then I'll share two technological solutions that can help reduce our impact, and I'll end with a reflection and a question for the audience. So what is the greenhouse effect? The greenhouse effect is a natural process. Sunlight warms the earth, and the earth releases some of that heat back into the air. Greenhouse gases like carbon dioxide trap part of that heat, which keeps the planet warm enough for life. Scientists have measured carbon dioxide in the atmosphere for decades, and those measurements show a steady rise linked to human activity. This increase strengthens the greenhouse effect and warms the planet. We know this is happening because scientists collect direct measurements. Carbon dioxide levels have risen sharply over the past century. Satellites show that more heat is being trapped in the atmosphere. Ice cores reveal that today's carbon levels are far higher than anything seen in hundreds and thousands of years. All of these independent measurements point to the same conclusion. The planet is warming because of human-released greenhouse gases. Okay, now let's talk about the carbon cycle. So, carbon naturally moves between the air, plants, ocean, and soil. Plants absorb carbon dioxide during photosynthesis. Oceans store large amounts of carbon in the water and in marine life. Soil releases carbon through decay. Scientists track this movement using atmospheric sensors, ocean chemistry data, and satellite observations. Okay, now let's talk about how fossil fuels disrupt the carbon cycle. Fossil fuels contain carbon that was stored underground for millions of years. When we burn coal, oil, and natural gas, we release that carbon into the air as carbon dioxide. This happens much faster than natural systems can absorb it. Oceans take in some of the extra carbon, which makes the water more acidic and harms marine life. Human activity has dramatically sped up the movement of carbon into the atmosphere. Ecological impact: rising temperatures. Scientists have measured a global temperature increase of about 1.37 degrees Celsius above pre-industrial levels. This warming has made heat waves more frequent and more intense. Many species are shifting their habitats to cooler areas. Temperature records from around the world confirm this long-term warming trend. Okay, the next ecological impact are ocean changes. Oceans absorb most of the excess heat from climate change. This causes coral bleaching, which damages entire reef ecosystems. Oceans are becoming more acidic as they absorb more carbon dioxide. These changes have been measured through long-term ocean monitoring programs. Let's talk about the human health impact. One is heat illness. Climate change affects people directly. Extreme heat events are becoming more common, and hospitals report more cases of heat stroke and dehydration. Elderly people, children, and outdoor workers are especially vulnerable. These impacts are already being measured in public health data. Another human health impact is the air quality. Higher temperatures worsen air pollution by increasing ground level ozone. Wildfires, which are becoming more frequent and intense, release smoke that travels long distances. This leads to more asthma attacks and breathing problems. Public health agencies track these increases through hospital records and air quality monitoring. One solution is renewable energy. Solar and wind power produce electricity without releasing carbon dioxide. These technologies help reduce emissions from electricity generation. However, we still need better energy storage and upgraded power grids to support large-scale renewable use. Another solution will be carbon capture. This technology removes carbon dioxide from the air or from industrial smokestacks. It can help reduce emissions from industries that are too hard to decarbonize, like cement and steel. The challenge is that carbon capture is expensive and requires a lot of energy. Okay, and here's my personal reflection. Before this course, I was aware of climate change but unsure how scientists connected it to human activity. Learning about the measurements scientists use to track human activity in relation to climate change helped me understand that studies overwhelmingly show human activity is responsible. I now have a clearer understanding and can explain how human actions affect the Earth's climate change. And finally, a question I have for the audience is, what is one change you believe could make the biggest difference for future generations? And as you reflect on that, I just want to say thank you for taking the time to listen to my presentation. My objective today was to show how scientists understand climate change through direct measurements rather than assumptions. When we look at the atmosphere, the oceans, and ecosystems, the evidence forms a consistent picture of how human activity is influencing the planet.